I want you to do the packet, but you probably should do a few extra problems. This is a problem, I believe it's in your homework. We have to figure out how to graph that. Okay, so first, I always like to do easy things first, and I feel better. Which one do you want? Well, do we even know what shape this is?
Parabola.
It's a parabola on its side, okay? What's this one? No, it's not a function. It's a line. So I know how to graph lines. This picture's going to be huge, by the way. So,
Your shirt is a parabola.
no.
Can you explain your shirt? I like that. Yes. What's he saying though?
I ate some pie. Okay, you guys ready?
Yeah, imaginary number.
That's right. It's I. Okay. You guys, when graphing something, I'll show you my trick to doing this. Is always, a table always works. Okay, Jack, Jacob, table always works. So I'm going to pick convenient points, like if x is 0. Well, if x is 0, then what's the y value? What kind of 16? Negative 16. If I let y be 0, what's the x value? 4. How many points do you need to have to determine a line? 2. So that's good to me. And it won't be exactly right.
Whoa, just to me. Free roll.
That's pretty good picture, actually. Okay. Now, to do the next one, that one's not as easy. But you know what we're going to do? We're going to take the minus 4x and put it on the right side. I don't even have to do that, but I kind of like to do that. Okay, you guys ready? Girls. Okay, guys, not right now. You'll have time. We're going to just do 2 problems. Okay, so if I do a little table, if x is equal to 0, then what's the y value? I get y squared equals 4. What other value? Negative 2. Somebody said it's not a function. You're right. It's not, but we can still graph it. What if y is 0? Hey, guys? If y is 0, I get negative 1. And I know it's a parabola opening to my right. I mean, I know that. So it won't be drawn to scale. We'll do the best we can.
Isn't it a square root?
It is if you solve for it, and it has a vertex at negative 1. So it looks like a parabola like this.
Oh, that's not like
Yeah. So the region I want is trapped between the 2 curves. And I'll just shade that. Only if you like that, you'll like the volume. You probably can on it. I know you can on an iPad.
It's not the same.
Okay. There's the region. Now what you have to do is decide which way you want the rectangles to go, horizontally or vertically. Let's see what green does. Well, if we do it vertically, here's a problem right here. Here's one problem. That's the upper branch of the parabola minus the lower. I can do it. It just takes more thinking. And then here, after I get to this point where they intersect, I switch to the parabola minus the line. So the problem is I have to write 2 integrals, and I like to avoid that. Hey, Alex, put your phone away, please. No, it's only rectangles, because these are going to be just areas. So instead of doing them vertically, why don't we do them horizontally? See if this one shows. Not too well, but you know what I can do? Hang on.
Or yellow. Try yellow. Or neon green. Yeah, that would show.
Okay, well, oh, that's much better. See, these are all rectangles. They're thin. I'll make one thicker. Let's make this one thicker. And here's the thing. You got to get the differential, because the differential is what makes the difference. So I could have used a crayon, too. Okay, Casey, don't throw. So here is the differential. Is it delta y or is it delta x? It's delta y. It's this thickness trapped between my 2 lines. That's the change in the y value. Another way to remember is that it hits the y-axis. So if you get the differential, then everything's going to work nicely for you, because the height will not be the same variable. So the area for one rectangle is equal to base times height, and the base is delta y, and the height is, well, it's this length right here. Which values are we going to use? I want this length horizontally, x or y? X. So call this one x1, and this one x2, and then what do I do with those to find that length? Careful, which way? The ones furthest to the right are bigger, so it's x1 minus x2. Is that okay? That's for one rectangle. We want them all. So we are going to add them all up with an integral symbol. I have to have an infinite number of them. So it's x1 minus x2. What happens to delta y when I become really tiny? Delta y becomes what? Gets close to 0, it's still there. It's the differential dy. That's what that means, that dy. So if you don't have a differential in your integral, it doesn't make sense, because an integral is always an area. Okay, Megan, phone flag, please. This is the base of your rectangle. That's the height of your rectangle. These will never be the same variable. Never. But now, what I have to do is I want the variables in my integral to be the same as my differential. That's why the differential is so important. Because once you decide that, you need to solve for x in terms of y. Okay, so I'm going to go up here and look at my equations. If I take this one, 4x minus y equals 16, I want to solve for x. So 4x equals y plus 16, and then divide by 4. There's that one. What about the other one? I need to solve this one for x. Put in green. So it depends on how you want to do it. I don't really care. You want to get solved for x. You got y squared minus 4x equals 4. So minus 4x equals 4 minus y squared, right? Is that right, Dave? Divided by what? Negative 4. That's a good question. How do I know which one x1 and x2 is? X1 is the one further to the right, which is which graph? The line. Now, if it's a setup and do not integrate, you have no way to check it. If you integrate and you get a negative answer, that means you did something wrong. Most likely you subtracted in the wrong order. This one's, if this is at 8, for instance, and this is at negative 1, this one's bigger than that one. And right, I want the furthest one to the right when I draw my rectangle. I could take the picture of this and rotate it. You'll see that it's actually the height. So which one's x1, the line or the parabola? Colin, which one is it? It's this one. It's this value right here. That's the line. So it's, what was the line? It was y over 4 plus 16 over 4. So it's y over 4 plus 16 over 4. It's that one minus, and then I have to have the other one. What's the other one? It's x2. This is x2 right here. What is that going to give you? It's going to give you y squared over 4 minus what? Over 4. I'm just cleaning up my signs. What is this if I simplify it? Negative y squared over negative 4 is positive y squared over 4. And a 4 divided by negative 4 is negative 1. You have to divide by the negative 4. So you add 4x. I'm sorry, I didn't add 4x. I subtracted y squared. There are a couple ways you can do it. So it's going to be minus 1. Did I do that right? And then it's dy. One last thing to do. Pardon? Mm-hmm. One last thing to do. What do I have to find now? No? And if it's in the calculator part, I'm not going to anti-differentiate it. I'm going to put up my calculator, let the calculator do it, if I'll do it wrong. No, there's no C. Where do I want to find the area? Between the points of intersection. Now, there's one point of intersection, there's the other, but the question question is, am I looking for X or am I looking for Y? Yes, because all these rectangles, the differential tells you it's Y. So I've looked through exams and I've seen the students not put the differential in. Well, then they don't get the problem right. Not because the differential's not there. We don't take off for that. But they do the problem wrong because they don't know which variable we're working with. So this always tells you the variable. So I need to solve this system of equations for y. So what I'm going to do is recopy them in a place where I have some space. So y squared minus 4x, whoops. And you guys should do it with me. Y squared, because we're going to see a trick here, is equal to 4. Is that right? Is that positive 4? Yeah. And 4x minus y is equal to 16. And I'm going to give you the hint right now, Noah, that you want to add those. What happens when you add those? It doesn't always happen. It does in this case. What happens? The x's add to 0. This is a positive 4x and a minus 4x. This is a non-linear system. You could solve for y in this equation and substitute it into that, or x. It doesn't matter. Okay, Casey? I'm just going to add these. What am I left with if I add them? Y squared. What happens to these guys? They go away. So it's minus y equals 20. No. Can you use zero product property on this? Is there a 0 in here besides in the 20? No. Zero product property says if you multiply two numbers and you get 0, one of them had to be 0. But I'm multiplying two numbers here, but I'm not getting 0, I'm getting 20. That's not going to work. Do you remember what I said yesterday? We always solve all equations by setting them equal to 0. And then what can we do? Now we can do zero product property. We can factor this. This is an easy factoring problem. Then they shouldn't be too much more difficult than this on the example. Y minus 5, y plus 4. So where are the points of intersection? Y equals what? 5 and negative 4. So where am I going to integrate from? We still start with the smallest, negative 4, and we go to the largest. Did I write that wrong? Oh, I did. I just didn't simplify that. This would be a 4, but that's okay. No big deal. And that's all there is. Well, it depends. If they said set up and do not integrate, you would leave it there. If it's in a graphing calculator section, I wouldn't even integrate it by hand. I would get my calculator out and let the calculator do it. We'll do it on the next one. Okay, so what we're going to do, you guys don't have it copied down. He does. I will save it and I will put it up on Schoology. And by the way, the answers to the packet are on Schoology, but you're going to have to open up the PDF files. We give you the year. This is 2003, usually problem number 1. Almost always problem number 1. But there's a folder that has the AP exams and solutions in it. Just open that up. Somebody said things were missing. No, nothing's missing. Are there more questions on this? Then what we did, so I'm consistent with classes, it was requested that I do 2008, number 1, which is on page 6 in the packet. So we should do at least one of these. Now remember, you have a quiz tomorrow. Okay, guys? Jack? And the problem is taken out of this packet. So if you've done the problems, then it's easy. And I'm not saying, but we'll do the same problem that we did in the other class. They asked me for, this is page 6 in your packet, and it's 2008, number 1. And I'm going to try and draw this thing. Well, we're going to do A and B because we can. The minute it talks about volume, no, we're not going to do it. I'll fix that. like a what? Looks like a bird, doesn't it? Bird. I think it looks like a bird. If I put an eye in it, it looks like a bird. Okay, there's my region. It says let R be the region bounded by the graph. I better write that down. Okay, guys, so as you're talking, try the problem. I thought more about it. I should have the last class. And they're kind of nice because they gave us the intersection points. We don't have to find them. And it says find the area of the region. That's it. Which way are you going to slice it? Vertically. Why don't I want to slice it horizontally? I've got two issues here if I slice it horizontally. I first have this issue. I can do that. I can solve for x in the sign for it's an inverse sign, and I know how you hate inverse signs. So that doesn't sound real pleasing to me. And I don't even know how to solve for x in the cubic. And I would have to do that to get those x values. I have to solve for x in terms of y. So that's a problem. I can't do that. So instead, somebody said, let's do it vertically. By the crayon. All we have are vertical and horizontal. There's my rectangle. Okay? Is that helping? Okay. What's the base of, you should be drawing this and doing it with me. It already has that written there, but it's hard to see. Is that delta x or delta y? It's delta x. I don't like to give you guys tricks. I don't like to see memorizing. However, it'll be delta x if it hits the x-axis, your rectangle. It'll be delta y if it hits the other one. But just look at it. This is the change in x. Okay, so the area for 1, I always do 1 first because that's an easier problem, is the height times delta x. How am I going to find this height? Which value do I want here, x or y? Y. I want the y coordinate. y1, we'll call that one y2. And I always do it generically. Some of you can just go right into the problem and set it up, but I still think it's better to look at it this way. It's y1 minus y2. That works for any graph. I don't care what those functions are. That's going to work when you slice it vertically. It's always going to be that way. So I'm going to integrate it, and it's y1 minus y2, and that's dx. Because when delta x gets really tiny, we want it infinitely tiny, then that we're going to call it dx. Okay? Now, because this width, if I look at this width here, that's the change in x. See that? Okay. What's the y value? Now I got to figure out which one's first. Which one comes first? The sine or the cubic? The sine. So it's the integral of the sine of pi x minus the cubic. Do I need parentheses? Yes, I do. If I don't use parentheses, well, I still could get the right answer. Yeah, it's the case of the missing parentheses. The 3 years I've graded, if you didn't put these parentheses around the cubic part, you still got your credit, as long as you got the right answer. And I'll show you how I'm going to put it in the calculator. Oh, now this one isn't too bad. Where are the x's starting? 0. Starting over here, and they're going to end over here at 2. That's all this integral does, is it finds the area of each individual one and adds them all together. Well, don't we have to integrate this? So I'm going to bring up my calculator. And here's the syntax. It's going to be FNINT y1 minus y2. Here's another reason why I like my little notation I do here. Now, only thing you're going to get credit for in the exam is this. If you choose to write FNINT and you kind of call that your answer, you will get no points for it. It's a function integration. And then it's 0 to 2. Oh, we're going to get there. I'm just giving the syntax. Now, in 2010 and 2011, they did not put this in the calculator section, but all the rest have been. So plan on a I don't know what they're going to do. Okay. I graphed it because we need it for the next part. I don't really need it for the next part. Well, yes, I do. Okay, so there it is. There's my little bird. Now, you got a problem here. You can't do, shh, guys. This integral function on the second calculator only gives you the area under the top curve relative to the x-axis. So the only way, if you want to look at the area visually, you're going to have to actually look at the graph of y1 minus y2. So I don't want to do that. So I'm going to quit. Now, wait, what did I have in y1? I have the sine of y1, and in y2 I have the cubic. And I'm going to clear my screen. Okay, you go to math. Do you remember where this is? It's 9. I can arrow down. That little arrow down here by 7 says there's more there. I know I'm not in pretty print. Enter. And then I want y1, so I'll do it the old-fashioned way, which is bars. Then you got to go to the y variable, function, y1. You have your calculator? No. Minus. Then for those who have the new operating system, you can do it this way: alpha, calc, and I just have a little shortcut bar here, which is y2, which is really nice. Comma, x, comma. Yes, you have to put these in y1 and y2. Comma, 2. Question? Is that okay? The answer is 4. Well, I think it is. I mean, I should check my mode. Math, 9. Yeah. And I forgot to do points here, but you will get points. I mean, I don't have the scoring rubric in front of me, so I don't exactly know where the points are. But usually it's going to be this. It's called an integrand. The limits of integration will give you a point, and the answer will give you a point. So this is 3 points. Hmm?
Wait, what's the second one?
1 point for the integrand. No, in order matters. 1 point for your limits of integration, and 1 point for the 4. What? I'm sorry, what? It takes into account that when you subtract. If this is a positive 2, and this is a negative 6, because you're going 2 minus a minus 6. Right. Okay, let's do the next part, you guys. Okay, you guys? We're going to do y equals negative 2. I need a different color, though. It says, and 2012 last year had a problem very similar to this. It says the horizontal line, y equals negative 2, splits the region, guys, into 2 parts. Right? But do not evaluate an integral expression for the area of the part of R that is below the horizontal line. So I want to put a horizontal line in here. And y equals negative 2, and I think it's going to be somewhere around here. You can do this without a cast. So I want this area. So let's look at it on our graphing calculator, because some of you like to see it. Okay, so I'm going to go into my y equals, and I've already typed in y equals negative 2. So y3. But now it's turned off. So I got to turn it back on so it'll actually work. You guys know about this? And then you just arrow over and press enter. Now it'll work. I just want to make sure I have that right. Picture's pretty good. Okay, Morgan? So what's that integral going to look like? I'm going to need to know something here. I never use zoom fit. I always figure out the window. Oh, here's my window. Thank you for reminding me. They gave us the 0 to 2. I know the sign doesn't go any higher than 1. The problem was getting the bottom part of the curve. And we just played with it a little bit, and I ended up going down to -4. Since I have my calculator up, what is it we need to do? I'm going to integrate. It says, take this. I want the area of the graph that's underneath this y equals -2. Okay, guys? Declan? I want this area. What do I need to find? Don't I need to know where the y equals -2 intersects the curve? Yeah, I do. And you can't do it algebraically. We're going to do it with the calculator. So let's do that. And we have 3 curves here. That's a problem. Yes, but we have 3 curves. I already messed it up once today. Second, calculate. And we're going to do intersect, which is 5. And you can go through this with the video later if you don't have your calculator here. I don't want that one. I want one of the lower ones, so I'm going to arrow down. So there's my first curve. I'll take enter. It doesn't matter where you are. Then my second curve is my line that I want. Enter. And I'm not sure which one it's going to come up with. Came up with the first one over there. So that's it. Click. So the guess is because there's more than one. So they want to know, where do you want to look for that? We could use that on the next one. Let's do that. I don't usually do that. So we're going to go to second, calculate. Right? Second, calculate. If we have to use this to actually integrate, you want all the places. But in this case, we're setting it up. So 3 is good enough. But we're going to write, I have mine written down. Intersect. And let's see, the first curve, no, I don't want that. Once we arrow down, I want that curve. And then I want the other curve, which is it's still on the same place, but that's okay. Press enter. And it should give me the guess. My guess is this was over by 2, so let's type in 2. Because it's going to look for the intersection point over here now. Otherwise, I just arrow over there, and there it is. Now we can set up the integral. Are you ready? How do you find this? How do you find this rectangle? The area for 1 is equal to the base, which is still delta x. And what's the height? Still y1 minus y2. So the area is equal to the integral. What's the top y value? Declan, what's the top y value? That's why you guys have to pay attention. -2 minus the cubic, which is x cubed minus 4x dx. And you know what? I wrote this down, and they only asked me to set up the integral. So I'm going to call this point A, and I'm going to call this point B, and then I don't have to recopy those numbers again. And I can just do A to B. As long as it's clearly written on my paper, I'm okay. And that's it. Because I want the height, and this is the y-coordinate here, is -2 minus this y-coordinate. This is always -2, because it asks you to find the area that's trapped under this line. That's what the directions say. And now what would that be worth? It would be worth, this is going to be a point, and that's going to be a point. So my guess is it's only going to be worth 2 points. In 2012, that was last year, if you look at that one, it says find the area of region R. Same question on the first one, different curves. And it says the region R, no, got to go to C. The horizontal line y equals k divides the region into 2 regions of equal area. Still the same kind of question, but they're just saying that the area below this equals the area above that. You're supposed to set up an integral to do that. You're going to write this integral, and you're going to write that integral, and you're going to set them equal. So that's what you did there in 2012. That did bother some people. Okay. That should be enough. Now you have looked at your individual tests, but if you want to look at it again, I'll give them back. Is that a yes or no?